So we're using an indirect way of measuring the statue. Okay, we're going to do that by comparing the shadows of the statue and the person beside him. All right, because the shadow of the statue is going to be proportional to the shadow of the person. So we're going to use proportions. So I'm going to do the person's height versus the statue's height. I'm going to make that equal to the person's shadow versus the statue's shadow, because they're going to be proportional to each other. So the person's height, 64. Shadow height, or the statue's height, do we know?
Nope.
It's X. The person's shadow is 32. And we use the statue shadow, which is 43.5. Everybody with me so far? So we cross multiply. 64 times 43.5 is 2,784. That equals 32x. So 32 times the number gives me 2,784. So I divide by 32. And I get the statue is 87 inches. So does anyone have any questions on how to use the shadows of objects to use it as an indirect way of measuring something? This down. This is an object, let's say called a bell tower. Gives off a shadow of 27.6 feet. A 6-foot person is standing by that bell tower and has a shadow of 1.2 feet. I need to know, how tall is the bell tower? So I need to set up proportions. So what I do is I'm going to do the person's height versus the bell tower's height. That's proportional to the person's shadow versus the bell tower's shadow.
Hey, say bell tower again.
So, person's height is 6 foot tall. The height of the bell tower is X. Person's shadow is 1.2. The bell tower shadow is 27.6. We cross multiply. 6 times 27.6 is 165.6. That equals 1.2x. Everyone with me so far? We divide by 1.2. So x is 138 inches, or feet here. 138 feet. Because 165.6 divided by 1.2 is 138. All right, write this down. This right here is supposed to be a pond. Okay, so draw the image of my pond right here. So a different way of measuring stuff. Okay, obviously a pond does not give off a shadow. So a surveyor who wants to measure a pond could not use shadow reckoning. So that's why we have another method. They call it surveying method. What they do is they set up two similar triangles. As you can see, we have one triangle here, STU, and then we have another triangle, which is VQU. What we're going to do is, since these are similar triangles are proportional. If you remember our rules from earlier, right? This says they're similar. So they can use similar triangles to measure distance. Because obviously, if we can't use a shadow to measure upon, can't use a tape measure or a ruler to measure upon, then we have to find an indirect method of doing it. So we use similar triangles. So we set this up as, I'm going to do QV, the length of QV on top. And I'm going to put on bottom the side that's proportional to QV. which is ST. Everyone see that? This side is proportional to this side. Okay, it's going to equal another proportion, which is going to be QU, this, over TU. Because this side is proportional to this side is proportional to this side, now we can find what X is. Is everybody with me? So, now we just plug in numbers QV. Okay, I need to make this more like a U. Okay, so we know the difference. QV is X. ST is 20. They're proportional. X over 20. I just need to know what is proportional to 20. And I find that out by taking QU, which is 16, over TU, which is 10. Now I can solve it. 20 times 16 is 320. So equals 10T. I divide by 10. If I take 10 out of each of those, I get T equals, or,
X.
well, it'd be X, yep, sorry. X equals 32 meters. Assignment.